All right. Translations of a graph. So the idea is it can either shift the whole graph up, down, left, or right. And the way you can tell by looking at the equation is whether or not something is being added to it. So if I have some function f, I don't know what it is, but if I add some k value to it, so like I have f of x plus 3, that's going to tell me it moves up 3. And the way this can look is, think about f of x equals x, the identity function, plus 3. And now I've just moved the identity function up 3. That's all I've done. Next up, we have a constant h when we add it to the input. So it would be something like f of x plus h. That is going to be a function that moves it left or right. Now, an interesting thing that happens here is when I look at this in the problem, so it's easiest to see in something like a quadratic. So let's say we have f of x equals x minus 2 squared. This tells me it's the same as the normal parent function for a quadratic, except it's moved to the right 2 units. So when you're looking at it inside, it's kind of different, but the whole idea here is it can tell you whether things move left or right when they're plugged in to the input of the function. So, example 2. Let's describe and graph translations. So we're going to describe the translation of y equals the absolute value of x plus 2, then graph the function. Well, what family does it belong to? It's an absolute value, right? Which normally is y equals the absolute value of x. And here you can see we just added in a plus 2 to the outside, which means it's going to move it up 2. So we say translated up 2. So here's the whole idea. If you know what the normal absolute value graph looks like, I'm just going to draw it here real quick. Not perfect. Wow. Now let me know what. That's absolute value. I'm going to use straight lines. So there we go. And let's have you go that way. Okay. So that is the absolute value function. This is y equals absolute value of x. Now in blue, I'm going to move all of those points up 2. So just think everything's getting shifted up 2. So if I have any point, it's just going up 2 units. And that's happening everywhere. It's just going up 2 units. You know what? I think I actually drew this one in the wrong spot. No. My graph is a little bit off here. Let me fix that. There we go. That looks better. Yeah, now that looks like an absolute value. So every single one of those points is going up 2 units. And the way I always like to do it, are there any like interesting points? Like, does it change direction ever? Or does it ever hit the y-axis? Those are the ones I'm going to look for. So the bottom is at 0. And now I'm going to make it 2. And I can see I move this one point up 2. I take this point and I move it up 2. And now you can see I've got my graph here. Let's do the straight lines again. It's got to go up that way. And it's got to go up that way. So this blue line is y equals absolute value of x plus 2. So we've graphed it and we've translated it up 2. Now in your work, you don't have to show the parent function. I just showed the parent function here so that you can see what's actually happening. It's like I'm grabbing it and just sliding it up, right? So in your final work, you don't have to have that red graph. You just need to have the graph of the actual function that it's given. And the idea is, if you can identify these parent functions and understand how the translations work, you don't have to make a table of values each time. Like, I didn't have to make a table of values because I know what the parent function for an absolute value of x, I know what it looks like. So I just shifted it all.